Hi, everybody. This is Dr. B. Welcome to online week 10 for level 1 chemistry, which way back in the day met on 7th period here at Guilford High School. I'm going to go over where we are and what the plan is for the week. You may recall that over the last couple weeks you prepared and then presented on a gas that you were assigned. We're in the gases unit. You talked about it, your gas, you answered some questions about it of a technical nature, and we're going to use that gas you selected to give you a test, and we haven't tested in a long time, on gases. The specific date of the test I'm hoping for today, but I'd like to discuss this with you briefly. When the test begins, I'll just post it to Classroom. You'll be then given an hour to complete it, at which point I won't accept any submissions. And what you do is answer about 8 questions about your gas on the test. Now, to help make things easier, here's pretty much what the questions are. I have also, for each one of these questions, presented about 6 days ago answers to all of these questions for not your gas, but the gas that we'll call my gas, which was oxygen difluoride, OF2, a scary gas which I actually had the pleasure of working with a long time ago. Okay, so here's what the test looks like. So do look online. There's the link to it if you want to watch the YouTube video after you read these questions to see how they are correctly answered for a different gas. So the questions will look like this. For every single student, we're going to pretend to give you 1 liter of a gas at regular atmospheric pressure, that's 1 atmosphere, and at 0 degrees Celsius, that's the melting point of water, of ice, I should say. And so that's 0 degrees Celsius, which, by the way, is 273 Kelvin. Don't forget to always use Kelvin for temperature calculations. And the first question will say, hey, if your gas is cooled to blank degrees Celsius, what phase will it be in? So I would make sure that I know the melting point and the boiling point of your gas under normal conditions. That means 1 atmosphere. And think about that. Question number 2, if you took your gas and raised it from that 0 degrees, as all questions begin, to a certain temperature degrees Celsius, what's the new volume? Notice in this case that we have T1 and we have a T2. We have a V1, we have a V2. This sounds like Charles's law. For all these questions, and it will say so explicitly on the test, nothing else is changing. So if it doesn't talk about pressure, that means the pressure is remaining constant. To keep the questions simple, I don't say that explicitly. It just makes it sound scarier than it is. But these are always, the only variables changing are the ones that they say. So if the volume is reduced from that 1 liter to some other thing, like, oh, I don't know, half a liter, find out the new pressure. So you got P's and V's there. Question 4, if the volume and the pressure change, what's the new temperature? That means you literally, if you think about it, you have 5 of 6 possible variables. That sounds like a combined gas law problem. What's the mass of your gas? You can solve that. Mass is usually coded in for moles. You can go from moles to mass, since for water, for example, 18 grams would be a mole. And so that sounds like an ideal gas law problem. This is perhaps one of the hardest ones, and that says if you took away a certain number of grams of your gas, what's the new temperature? That's not really that hard when you think about it. For here, we have a certain number of moles of gas. They literally, you've calculated it there. Here, your N is a different value. So you have a fewer number of moles of gas. Get it from grams, go to moles, find the new temperature using PV equals nRT. Don't forget that's the Picky law. Liters, atmosphere, mole, Kelvin. How could you turn your gas into a liquid? I suppose I'd give you a tiny bit of partial credit if you said, well, cool it down. I'm a little more interested into cool it down to any temperature below blank. So that should help there. And a bonus question, which I won't say anything about, but I hope you guys put some thought into it. How much pressure would be needed to turn your gas under these conditions into a solid? Isn't that interesting? You should be able to solidify a gas just by pressing down on it, giving it some pressure, all right? And once again, if you're having trouble with these or you really want to do well in the test, take a look at it for each one. I would rehearse all these questions in advance so that some of them I think can be done completely, not even knowing what the new temperature would be, but I'd at least give these a practice try. If you want to contact me, if you want to do a review, a group review, we will be spending the rest of the time in our normal class meeting reviewing sample questions. But if you want to meet up with me, just let me know. If you want to have a group review, say this evening, for example, I could do that too. Okay, everybody, that's the plan for this week. Don't forget, it'll apply to your own gases. I'm just going to page through some of these here. Here were all of your wonderful gases. Right, so here's the students. Rachel had phosgene, Brooke had methane, Justin had smelly sulfur dioxide. Yikes, Krypton was somebody, Gianna there, and there you go. So I'm going to end now. Good luck on our gases test.